All right, folks, we are back again. Next question that we have from here. In general, when thinking of magnetic induction of electricity, less wraps of wire or less loops means what? And I realize after the fact this isn't the most well written question, but what I was looking for is less wraps ends up being a lower voltage, okay, which is the last one here. And let me show you what I mean by that. Okay, I want to do a demonstration for you. And remember, it's talking about induced electricity, okay? So here we have, back to our CK12 demo, we have a uh, primary line coming in to a transformer right here. And then we have a secondary line over here, which goes out to this light bulb. Okay. This primary one has voltage on it that says electricity coming in. And the transformer is inducing electricity over here by using the magnetic field. So anytime we're talking about inducing electricity, we're using the magnetic field to induce it. So I want to show you how this works. Now, I set my primary voltage to 1,200 volts down here in the bottom. I have this at AC, not DC. DC would completely change everything. I have it on AC. That's why you see the hertz. It's operating at 60 hertz. So I got 1,200 volts on the line. On my transformer, I have 50 wraps on the primary side, and right now I have 50 wraps on the secondary side. So if you look up here at the top, right there is 120 times 10, so it's 1,200 volts. You look over here on the secondary side, and I have 1.2 times 10 to the third, which is 1,200 volts. It's the same thing. There's no change in them. 50 reps on one side, 50 reps on the other side. My magnetic field that I'm producing is inducing the same amount of current in the other side, on the other side of the transformer. Now, let's change this to do 100 reps on this side, and I'm going to leave the other side at 50. So now, in essence, instead of reducing the secondary side, I increase the primary side, which is sort of the way that I'm reducing the secondary side. I'm making this smaller in comparison to the other side. But look what happens to the voltage. My input is still 1,200, but what's my secondary? Now it's 6 times 10 to the second, which is 600. So look at the relationship between the windings. The secondary side has half as many windings as the primary side. And what happened to the voltage? It got cut in half. Let's do this again. Let's change it to 500 windings. Now I have 500 windings on the primary side and only 50 on the side where we are inducing electricity or creating it. So I still have 1,200 volts up here, right? I haven't changed anything on the primary side. Just we have more wraps over here than we have over here. But what's happened to the voltage on the secondary side? 1.2 times 10 to the second, which is 100. So 1.2 times 100 is 120. So what did I do? We've now changed 1,200 volts into 120 volts that we can use in our home. How did we do that? We have 1/10 the number of wraps on our induced voltage side as we do on the other side. If I increase those wraps, let's say to 100, look what happens. All of a sudden, my voltage goes up to 240. If I increase them to 500, all of a sudden, my voltage goes up by the exponents here to 1,200. It's the same. So my voltage on the induced side is equivalent to the ratio between the number of wraps